Okay, so here's the idea. I want to modify this capsule and make a figure of 8 push-pull single diaphragm capsule. I'm going to take the diaphragm, which is now in front of the capsule, and move it to in between the back plates. So it will be here once we're done with the modification. So the first thing we should do is to split the capsule into halves. And there are 2 screws that, or 4 screws that hold the capsule or the 2 halves together. Now I need to find them. But since we need to disassemble the whole capsule, I'm just going to remove all of the screws. I'm not particularly careful with my screwdriver here because I don't care if I'm gonna puncture the diaphragm or not. Okay, I believe this screw is longer. Yes, so this is the screw that holds the 2 back plates together. This one should be longer as well. Yes, so and there should be also 2 of these longer screws on the front side under 90 degrees angle. It is really tricky to do this while recording the video at the same time. Yeah, so there's 2 screws. 2 of them here. And here we go. Now the capsule is split in 2. Now the point here would be to move the diaphragm from here, from in front, and move it to in between the back plates. However, we need to widen these holes. As you see, the capsule has these through holes and blind holes. We need to widen these holes so that more of the sound gets through. I hope that makes sense. However, I'm not going to make a video about how I'm going to drill these holes through because it would be way too complicated, but the point would be just to make these holes wider. Okay, now you can see here I have widened the holes on this back plate. So of course you need to make sure there is no debris from the drilling. The surface needs to be perfectly clean. The diaphragm will be on top of this part of the back plate. So it needs to be perfectly polished. This side is not as important because as the diaphragm will be here, it's important that we don't have anything sticking out here. It needs to be perfectly clean. And now we go ahead, disassemble this half. Let me see where my camera is. It's kind of tricky to record this stuff. Usually you would need to be really careful not to damage the diaphragm, but since we are modding the capsule and since we are removing the diaphragm altogether, I'm not particularly careful here. There you go. The diaphragm, and also the moment of truth. We'll find out if the diaphragm is glued on these capsules. Yeah, it's actually glued. And we can figure out the frequency or how the diaphragm is tensioned by blowing against it and listening to the tone. I don't know if you can hear it. I'm just blowing. I'm just blowing under this angle, and you can hear the capsule. And now we can just find the pitch of this note and figure out how the capsule is tensioned. I would guess it's somewhere around 1000 hertz. Plus minus maybe 100 or something. But yeah, it is glued on this capsule. And now we need to widen the holes on this back plate as well. Okay, so now we have both halves widened. So eventually we will sandwich them together and put the diaphragm in between. Now that I've done this, I need to make sure there's absolutely, like you can see here, there must be no debris left. So I'm just going to make sure these two sides are perfectly clean. There's no debris, no dirt, no nothing, because the diaphragm will be there. So here we have two perfectly cleaned halves, and the idea now is to put this half, then one spacer, then diaphragm on top of this, the other spacer, and then this half on top. Hopefully we'll pull it off and we'll get our figure of 8 symmetrical single diaphragm capsule. Now here we have a piece of 10 micron mylar, which we're going to tension on top of this 250 grams weight. And I'll be using my proprietary technique of tensioning the diaphragm onto the weight with some tape. You need to be careful not to touch the mylar in the mill where it will be placed on top of the back plates. It doesn't have to be done perfectly because the tension will be determined, final tension of the diaphragm will be determined by the weight itself, so it is important to do it, to stretch the mylar as even as possible, but the final tension will be determined by the weight itself. Also, one side of the mylar is really conductive while the other isn't, but since we're making a symmetrical capsule, it doesn't really matter which side will be conductive and which won't. Doing this and recording it at the same time is usually, I'll be way more careful with all of this, but for demonstration purposes I think this will do, and hopefully it will work in the end. So, and of course you can undo some of the tape and redo the tensioning in order to get the perfect result. Okay, this came loose. I actually think this is good enough. I'm just going to secure it some more, because once we leave it hanging, some of the tape might become loose. I mean, if it doesn't work for whatever reason, you can always start from scratch, but it can be really frustrating. Now I'm going to use, this is just a perfume bottle cap that I use, and it has some of the dual side tape. So when I put, let me see, okay, this side, right, when I put some of this here, yeah, it sticks to it. And now the point would be to put this thing somewhere. I'm going to need some light so that I can see. You see the point? Now I can see. Now I can easily center the diaphragm. But now first, and yeah, let me just show you. Yeah, this would be the idea. But, and now you can see why we need this tape to work and stand still. It came loose somewhat, so maybe I'll do just one more round and tension it some more. Okay, hopefully now this is the trickiest part, and I'm going to try. I need to mark these holes and figure out. Okay, so we have the screw. Two of the screws will come from here, and two of the screws that come from the top will have to come there. So let me see. This guy, okay, here we have the two wide screws or holes, and two of these under 90-degree angles. So these, let me see, these wide will have to fall, oh, sorry, there. it will come together this way. I hope this makes sense. It's incredibly tricky to film this and keep everything clean and perfect and precise, but this would be the idea. Yeah, these will come together that way. So I'm just placing this one here on the side, making sure there is no dust coming. Now we need to use one spacer on top. Let me use some light so I can see what I'm doing. Yeah, it will. Hopefully everything is still aligned. Now, this is tricky as hell. Now I forgot where the hole, okay, the holes are there. So we have two of the holes here. Two of these holes there. Hopefully the spacer didn't move. And now, this is improvising big time. I need to puncture the two holes. Let me just double check, is everything still aligned? And now the two holes. You can notice how shaky my hands are. Two holes should be there somewhere. There it is. One hole, and the other one is here, right across. And now we put the other spacer. I need a brush for that. Now, two of the longer screws come in. Let me see where the wide holes. Here are the wide holes. Needless to say, oh, okay, I forgot one thing, which is quite important. We need to have these here. This is extremely tricky to pull off. And my hands are shaking on top of it. And you need to be careful not to get any dust on the diaphragm or in between the back plates. So this is extremely tricky. So now we have these two and they need to come in. Okay, you're not seeing these. Okay, now we have these two. They need to come right screw into these two holes. And hopefully we will get it done from the first go. If not, okay, this didn't work out. And for whatever reason, this morning my hands are really shaky. Maybe, just maybe I made it. Seems to be fine on this side. here as well. So tighten it. Yeah, we've made it. At least one side. Slightly wider screwdriver head. Okay, this won't work. Tighten it. Yeah, I hope it's good enough. Now we need to turn it on the other side. And we have some double tape here, which doesn't help right now. Yeah, it comes off. I don't know if I should use something else at this point. No, actually I need the tape, this sticky tape, to hold things in place. Now, okay, so the two screws, let me see if I can move this a little bit towards me, yeah, like that. Now we don't need the diaphragm any longer. No, it wasn't particularly, it was glued, but not, there's not a lot of glue there. Here we have the two wide holes here. Now you need to be really careful right now because the diaphragm is now tensioned in place just by these 4 screws, 2 on each side. So there's not a lot of tension holding the diaphragm in place. Hopefully these 4 screws will be enough. Hopefully. Of course you can, and that's exactly what I'm going to do. I'm going to use some extra screws. Unfortunately I don't have any extra screws, so hopefully 4 screws will be enough to hold the diaphragm in place, and we'll figure out if that is enough once we, and now we have another issue. We have another issue. I'm not getting enough of tension here. So this screw hole is blown, which means I need to go one up. You need to be careful not to puncture the diaphragm now while it's under the tension, because that would ruin. No, okay. This one holds pretty well. Do not over tighten it because you will blow. You will blow the hole, just like I did. You know what? This hole is also blown. So I need to move this screw as well. The worst thing is that you don't really know if everything is okay until you're done and until you hook up the capsule in a circuit, especially with this. Yeah, it seems to be holding. Now let me check the other side. We have no idea right now at this moment if everything is okay. How well we have tightened this. Now there is one thing we can do right now to check if we're anywhere near done. We can check capacitance between let me see. Actually, I think I'm gonna need to flip this because conductive part will be here on this side. I'm going to try to measure capacitance. 69 picofarads. Can you see what I'm doing? Yeah. 69 picofarads, and the good sign is that we don't have any connection between our diaphragm and this back plate. This is really good sign. Really, let me see. 67. It's perfect. Dang it. Now we have the diaphragm, we have one side, we have the other side, the capacitance. You can see actually now the diaphragm in between. So hopefully the tension is good, and these 4 screws are enough to hold the diaphragm in place. Of course, the issue I have now is that I don't have any extra screws of this length, but the point would be to use all of the holes so that we have a stable diaphragm. We use these holes to make electrical connection with the back plate, and we need to figure out a way to make a connection to the diaphragm. Okay, so I came up with this idea to use epoxy instead of screws to hold the diaphragm in place, which might work even better. And now I'll just use my trusty screwdriver to glue the diaphragm in place. Go just all the way around. Okay, the capsule is assembled and it works like a charm. Measures great. I have about 70 picofarads from each side. You can see here how I assembled, or how I connected the diaphragm. I used one of the holes, however the screw is much shorter, so it doesn't go all the way through to touch the back plate. And I used some extra epoxy to hold things in place. Right now only one back plate is connected. The other wire goes to the diaphragm, and eventually I'll also connect the other back plate depending on how I want to use the capsule, if I'm going to use it in RF circuit or if I'm just going to use regular polarization scheme.